Okay guys, I guess welcome to part 3. Well, not really. I just recorded my deserialization tutorial on how to do secure programming practices for serialization and deserialization, and I was reviewing what I've recorded and have to issue a couple corrections. One is a pretty bad bug, and the second one is the place that I omitted that I kind of decided to add. So if you look at my logic, for instance, for when I'm deserializing my class, when I get any kind of a size from the outside, right from the user, I always check it to be negative and break if it is. But in one of the places, like for instance, if we look at the checks here, well, it doesn't need to be because we get the size from the size of the variable, so this part is correct. But if you look at my template that is actually dealing with reading the string, I read the size from memory and to CZ, but then I do not check it from being negative. So this is a pretty nasty bug. Let's see what happens if this thing, let's say, is negative. Obviously, size t cannot be negative, but it doesn't stop the person from providing a negative number. When we add pointer to, let's say, -5, it will be a huge number, so it will cause an overrun. So if the pointer is here, we will end up a little bit before. So this is definitely would be, it wouldn't be greater than the end, but it will allow us to read from before our appointed buffer. So this is a pretty bad bug. So let's correct it. Now this is a good example how you can make mistakes. Yeah, it's just this stuff. If I, let's say, was writing this serializer and put it, let's say, into a kernel mode or into some very important part, like a browser that was parsing something, with this little omission, someone could have exploited my code. Again, I didn't do it on purpose, and I don't really want to justify me making this mistake. I obviously make mistakes. It is obviously difficult to record yourself, to describe all this stuff, and also kind of sound coherent. But excuses aside, this part that I highlighted is very important. And what we're doing here, we're basically checking if our size that we just got from memory is actually valid. If it's negative, we break, right? And if it's positive, then yeah, we move forward and then we check if it doesn't overrun. So this part is, yeah, definitely bad bug. So again, please make sure to follow it, and I'll update it in my GitHub. And let's kind of check the rest of them. And it's only in the reading logic. Okay, this one it doesn't apply because the size is technically constant. And okay, copying, again, that doesn't apply. Okay, so that was one thing that I wanted to correct, and obviously really bad bug. And the second thing is this double variable, right? Performance score. If we look it up, over here, we simply read, and we're doing this again just to remind you from our deserialization logic for the student class. So we read the value and we don't really check. If you watch my part 2, I kind of glanced over it and I said, like, yeah, there are some edge cases, but I'm not going to check it. I should check it. So let me go and rewrite it. Not rewrite it, but I will create a separate template specifically for reading doubles. Right, so, and what this macro will do, it will read a double. Now, instead of telling you, let me just type it in here. So it will read a floating point type from memory. And let's do the same. So it will set floating point type. And what it will do, it will read it from memory, right, at this location, and it will check for the number to be the actual number, right? Because if you kind of know doubles or floats, there's a whole host of things that they can encode, anything from infinities to like not a number to errors. And yeah, we don't want to deal with this when, let's say, our performance score can be just a number, right? It can't be infinity. So we need to kind of cover that. And I'm sorry for skipping it over. That wasn't a good thing of me. So what I will do, I will copy our code that we already had. And over here, we will return false. If you remember our template, which I keep calling macro, and again, all of these are templates, it returns false if we failed. And in this case, if we failed to read our variable over here, we fail. But then we need to check to see if this thing is actually a number. Now, there is a C++ function that is called isFinite. And to make sure that it works, we need to include cmath. And what this thing does, it checks if this number is finite. In other words, if it's any of those infinities and such, it will return false. And in that case, we also return false. Because, you know, we don't care about infinities. Check for infinities. And let's say not a number and such. And yeah, in that case, we don't care. And if it is, you know, if it is finite, we basically return true. And the only thing we need to do, we need to call this thing here. And let's put a breakpoint and build it. So let me make sure I removed my fuzzer, which I was testing in the last part, and I did. Okay, so let's run it. Okay, so at this point, let's step in. So we read our value, which happens to be 12.5, and it is finite, and we return true. So, and this is how we can actually see that our floating point number is actual number. Okay, and one last thing that I didn't show you, let me remove all the breakpoints. So when I get to my de-serialization logic, I didn't show you what is actually inside my class here. So if we run it and deserialize it, so if you remember, my class contained, like, you know, nodes, blah, 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 and all the students, which you kind of see, John Doe, Mary Smith, Kareem Abdul-Jabbar, Rihanna, and the dopey kid named Unruly Kid with -5 performance score. So then when we deserialized it, so technically our class should contain the same stuff, right? So as you can see, John Doe, pretty much the same. Mary Smith enrolling with the high score. Kareem Abdul-Jabbar with amazing score. Rihanna with her celebrity endorsement. Again, pretty much everything should match. And Unruly Kid that dropped out with the -5 performance score. So this is technically something that probably should be working. Again, unfortunately, with these kind of stuff, there are always things that creep up. And the thing that was absolutely horrendous for me to do was to miss this part. Because again, this is very, very bad bug that could have cost, well, someone pretty much an exploit. So again, guys, this was a very short correction to my part 2 of the serialization. Thank you for watching, and I'll see you all next time.